All right, let's go over these problems here, our practice problems for today. Name the circle. Okay, remember circles are only named with their centers. Okay, that's how we name circles. We name circles with the center. Well, the center of this circle is C, so answer would be circle C. Okay, and circles are always named by their centers. Name two radii. Well, remember a radius starts at the center of our circle and travels to a point on the circle. So our radius must have point C in it. Well, the only two with point C in it are AC and CD. All right, they start at the center and go to a point on the circle. Okay. Let's go with 3. Name two chords. Remember, chords are segments that whose endpoints has 2 endpoints on the circle. So AC has an endpoint at the center. That has to be out. AD, A to D has 2 endpoints that are on the circle. That works. BH has 2 endpoints on the circle. That works. GF, it has has 1 endpoint on the circle, but needs 2. KG, KG goes through the circle. All right, K is not on the circle. G is not on the circle, so that one is also out. All right, that's why those 2 are out. Name the diameter. Well, there's only one because there's only one segment that has 2 endpoints on the circle and goes to the center, and that is AD. Here we go. We're cruising. Name a secant. Remember, secant segments see through the circle. FE does not see through the circle. DC is a radius. EG is not a secant. It's actually a tangent. GK is the only segment that goes through the circle like this, K to G. And remember, we need to have those arrows over the top like that. Okay. Name a tangent segment, all right, and a point of tangency. Well, a point of tangency happens when the tangent segment meets the circle. So HK is not a tangent segment. GE is a tangent segment. AD is also not a tangent segment. Our point, so if this is our tangent segment here, because it takes a tan, it touches it once, it touches at F. So our point of tangency is F, and GE is our tangent segment. Wow! Here we go. Okay, tell whether it's tangent. All right, so we want to test if it's a right triangle. Okay, so again, remember we want to do the Pythagorean theorem. Some of you may recognize that this is a triple. 3, 4, 5 is a triple. All right, but if you didn't, that's okay. That's 25 equals 25. So look, oh, check. So yes, this is a right triangle. So yes, this is tangent. Okay, remember, if in order for it to be tangent, it has to create a right angle, which means I have to have a right triangle, which means the Pythagorean theorem has to check out. Whew, that was a lot. B is the point of tangency. Obviously, you can see the correct answer here. That means this is a right angle. All right, so I need to do the Pythagorean theorem. R squared plus 24 squared equals R plus 16 squared. R squared plus 576 equals, remember this is R plus 16 times R plus 16. Okay, so I have R squared plus 576 FOIL. Multiply our binomials. If I combine like terms, I should get 32R plus 256. R squareds cancel. Will that always happen? No, I don't like saying always, so I can't say always there. 576 minus 256 is 320. 320 equals 32R, so R is 10. The biggest mistake people make is this part right here. All right, understanding that it's not just R squared plus 256. I actually have to FOIL. Okay, biggest mistake. A lot of people make that mistake. All right, it says B and D are points of tangency. Now this was in our notes, but I didn't do a problem like this. We can handle it. So if they're points of tangency, that means if they start from the same point, all right, these are congruent. So I said 2x squared plus 4 equals 22, and then solve for x. So 2x squared equals 18. X squared equals 9. You have to divide by 2 before you can take the square root, okay? I have to divide the 2 before I can take the square root. Now to get rid of a square term, I take the square root to x equals 3. Now, usually here we would write plus or minus, right? But since we're talking about a segment length, if I write -3, -3 squared is 9, negative. You know what? I started making an argument with myself. I think it should be plus or minus. The book just has positive, but I think it should be plus or minus 3. This is where I'm going to disagree with the book. Because if I square -3, I still get positive 9. Times 2 is 18, plus 4 is still 22. So they both actually work here. Just be careful with your negatives. Okay, be careful. All right, so now this one I'm going to set 3x squared plus 2x minus 7 equal to 2x plus 5. All right, well, my 2x's, hopefully you can see those are going to cancel. And then I'm going to add the 7 over to get 3x squared equals 12. Remember, you have to divide the 3 first to get x squared equals 4. Square root both sides, x equals plus or minus 2. Now, this is where it could actually not work. Well, let's see. -2 here, that would give me -4. -4 would give me 1. -2 here, that would give me -4. -4 times, or excuse me, that would give me positive 4. That's 12. 12 minus 4. 12 minus 4 minus 7. That would also give me 1. So actually, plus or minus yet again works. I tend to disagree with the book again. Shoot. Everyone makes mistakes. All right. Don't be like the book and automatically throw out negatives. So describe the error, all right, that this person is making. Okay. Let's see. Because 11 squared plus 60 squared is 61 squared, this is a right triangle. Well, the right angle is not angle Z. That's right. It's not. What the heck? The right angle is Z, not X. Okay, so that is actually, what? Hold on. That is confusing. The right angle is Z, not X, so this is not tangent. All right, so I think X is the right angle, but in this problem, like, if you were to solve the using the Pythagorean theorem, when we're doing this and we're checking our answers, right? And I'm checking my answers for this, okay? So I have y, x, z, all right? No matter how it looks, I know it doesn't look like that. This is what, 60? This is 61, and this is 11. I hear what they're saying. So based on this picture, okay, 61 would have to be our C value because it's the longest side. That would make this angle here the right angle. Well, it's not the right angle. It can't be the right angle. The right angle has to be here. A tangent line makes a right angle with a radius. A radius doesn't make a radius is not perpendicular necessarily to this line ZY. This is a secant, first of all. Secant lines will go through. This would extend out to be a secant, okay? XY, I'm going to say, oh, wow. I think you probably just got confused, all right? So when we have a tangent, XY needs to be perpendicular. That would mean that 60 would have to be our C. Well, C cannot be 60 because 60 is not the longest side, okay? Therefore, this can't be a tangent line, all right? Had these two flipped, maybe it could have. If this was 60 and this was 61, then yeah, maybe that could have been the tangent line, all right? But it's not. So it's not. Let's see. Describe the error making and finding, blah, blah, blah. Okay, so 39 squared minus 36 squared is equal to 15 squared. Okay, so the diameter, so this whole segment is 15. Okay, the whole segment is 15. All right, well, the radius is half a diameter. All right, so 2 radii make up 1 diameter. If you think about this, if I think about a diameter here going through the circle, all right, it's a pretty poorly drawn circle. Actually, it's not that bad. Kudos to you. Thank you. All right, this right here is a radius. This right here is a radius. So 2 of those will make up 1 diameter. So to find the radius, if I have the diameter, I just divide it by 2. All right, so the radius is actually 7.5, not 15. Okay, those are homework problems. Hopefully that helped out. Deuces.